You probably learned that there are two types of animals. Warm-blooded ones, which generate heat internally and therefore keep their bodies at a consistent temperature, and cold-blooded ones, which rely on the environment for heat and therefore have body temperatures that fluctuate. But that's basically wrong. When you try to actually categorize animals by their temperature regulation strategies, they don't fit neatly into two buckets. Let's take a look at how animals generate their heat. Mammals like humans and bears and hedgehogs mostly generate their heat internally, putting them over here. But other mammals, like naked mole rats, have mostly lost that ability because they live in underground chambers with natural year-round climate control. So let's put them over here. And while many reptiles and invertebrates and fish have to get most of their heat from their surroundings, and thus go here, some, like honeybees and tuna, can also use their powerful muscles to generate heat internally. So they go closer to the middle. Honeybees can actually generate so much internal heat that they can collectively cook invading hornets. So how animals generate heat is way less of a split than a spectrum. But wait, the ostensible purpose of being warm-blooded, that you'd keep your internal body temperature consistent, doesn't hold true either. Even though a bear generates its own body heat, when it hunkers down for the winter, its body temperature drops. So we need to add another dimension to really represent all the different temperature regulation strategies out there. And immediately you can see things get even more complicated. This chart allows us to show that some so-called warm-blooded animals, like hedgehogs, occasionally let their body temperatures drop even further than bears do, to almost freezing. And that the body temperatures of some so-called cold-blooded animals barely change at all. Leatherback turtles, for instance, are so massive that they don't lose much heat no matter where they are. And you can even see that your human body temperature isn't always constant. It does vary a bit over time. But wait, there's even more weirdness. Penguins, for example, generate heat internally and keep most of their bodies warm at all times. But they let the temperature in their feet fall to just above the ice that they stand on, which means that, on this chart, their feet are here while the rest of their bodies are over here. And marlins have co-opted optical muscles to keep their big eyes and brains warm, while the rest of their bodies get cooler and warmer based on their surroundings. So their bodies are here, while their heads are here. And that's without even getting into other aspects of temperature regulation, like all the different ways that animals cool themselves. So why do we continue to try to lump all of these diverse strategies into just two buckets? Well, the same reason we tend to divide lots of animal traits, like their diet and their intelligence and their mating system, into discrete categories, despite the fact that they don't actually fit into those boxes. We divide them because of historical inertia and because human brains like to label things in black and white terms, even when the truth is often more complicated. In order to truly understand what's going on, though, we need to disregard those very human sentiments and instead follow the facts. That is, sometimes even so-called warm-blooded animals have to be a little cold-blooded.